the general term of the binomial expansion. Do not forget to subscribe, and if you have any question, feel free to ask or suggest anything. Suppose you are asked to find the seventh term in a binomial expansion such as you should expand the binomial to get the seventh term, but the process is time-consuming to complete. So we use the binomial theorem to find a particular term of a binomial expansion without having to find the entire expansion. It's common in examinations for questions to only ask for a part of an expansion. We have already seen the relationship between Pascal's triangle and the binomial theorem. From this relationship, we were able to produce the binomial theorem, that is, now we use the binomial theorem to express the binomial in expanded form. Note the pattern of coefficients in the expansion. When we are looking for the first term, the bottom number of the binomial coefficient is 0. When we are looking for the second term, the bottom number of the binomial coefficient is 1. When we are looking for the third term, the bottom number of the binomial coefficient is 2. When we are looking for the fourth term, the bottom number of the binomial coefficient is 3. We should notice that the bottom number of the binomial coefficient is 1 less than the term we are looking for. In general, any term of any binomial expansion can be expressed as follows. The general term is used to find out the specified term in the binomial expansion. Let's see how it works. Find the seventh term of the expansion. As we have to find the seventh term, we are going to need to use the general term formula to help us with this task. Replace n with 13, k with 7, x with a, and y with 3 times b. Evaluate inside the brackets. Expand 13 factorial until it gets to 7 factorial, which is the larger factorial in the denominator. Then simplify by cancelling out like factors from the numerator and the denominator. Find the coefficient of x to the power of 7 in the expansion. To begin, we write the general term formula. Replace n with 6, x with 2x squared, and y with minus 3x. Now let's rewrite the general term formula. The exponent needs to be applied to both the variable and the coefficient. Notice how we had to separate the constants and the x terms. After tidying up the mess, we equate the power of x in the expansion to 7. K equals 6. Replace k with 6 into the general term formula to find the sixth term. This is the answer.